Welcome to everyone to my channel. Today we will discuss lecture 3 from our DSF playlist, and today we will be discussing about selection sort. Selection sort, just like any other sorting algorithms, is used to sort the array. And how does it works? I will show you with the help of a particular example. Let me take an example: 5 1 3 0 minus 1 2, and we will be performing our selection sort on this particular array. Okay. In order to understand selection sort in depth, we first of all need to consider 2 to 3 variables. What will be those variables? An I which is being incremented from an I which is being incremented from 0 to n minus 1, where n is the size of the array. A j, a j which is always being incremented from I plus 1 to n, I plus 1 to n, and a minimum index or a min index, a minimum index or a min index which is always pointing towards I, and in between this we will perform some another logic in min index to find the smallest element within the array to the right side, okay, of I. Now what did I told? And in order to understand it much more in a clearer way, let me do one thing. Yeah, I will point I as a white arrow, point our J as our red arrow, and min index as our blue arrow. Okay, this will be our 3 pointers. So initially, min index will be pointing at I. Initially, min index will be pointing at I. So what is happening now? Min index is at I. I is pointing to its the first place at the starting of the array, and J is pointing to the second index. Let me do the indexing for this: 0, 1, 2, 3, 4, and 5. Okay. So now let's begin with our logic. So what the logic is says is basically it uses j and min index to find the smallest element on the right side of I. It uses j and min index to find the smallest element present in the right side of I. And at last, sorry, and at last, if there are no more elements left, no more elements left, that is j reaches n minus 1 index, j reaches n minus 1 index, or j reaches here or n minus 1 index, then or if there are no more smaller elements left, then what we do? We perform a swap operation. We perform a swap operation with whom? Between arr I and arr of min index. Between arr of I and arr of min index, we perform a swap, and that basically gives us our result. Okay, I hope you got it clear, and it will be more clear as I show you the explanation down the array as I perform the selection sort on this particular array. Okay, now let's see. So tell me, j as j is pointing towards 1, is we need to find the smallest element of the right side of I, right? So what is the smallest element at the right side of I? Uh, 1 is smaller than 5. Very good. Increment 1 is smaller than I. Increment j. If 3 is smaller than 5, yes, increment j. And our mean index will be pointing towards the smallest element right now. So it will be pointing towards here. That is 1, because until now this is the smallest. Right, until now this is the smallest. Until now the 1 is the smallest element, and our j reaches 0. Once j reaches 0, then the most smaller element is 0. The most smaller element until now is 0. So our current mean will be pointing towards 0, and j is incremented again. J is now pointing at minus 1, and now as you can see that minus 1 is the current minimum, means minus 1 is the most smallest element on the right side of I. So again, what happens? Current min is pointing towards minus 1 as it is the smallest, and j is again incremented 2. J is again incremented to 2. Is 2 is smaller compared to 5? Yes, 2 is smaller compared to 5, but is it the current mean? Is it the current minimum? No. 2 is smaller than 5, but 2 is not the smallest element. Which is the smallest element? The smallest element is minus 1. Right, the smallest element is minus 1, and the smallest element is minus 1, and our current minimum, or let's say our min index, let's say our min index is pointing towards the smallest element, minus 1. And what we will do, we will just swap the location. Swap the location of our with the array of I. I is pointing towards 5, and our minimum index is pointing towards minus 1, and we will swap their location. So this will something look like this. Sorry. After swapping their location, the array will become something like this: 1, 3, 0, 5, 2. Now I gets incremented by one index. I gets incremented by one index. Our current mean is also initially stating there only, and our j is initially at I plus one index. And now we will perform the same process again. And once we perform the same process, let's see what happens. Again, our j is incremented 0, and until now, which is the current minimum? Until now, which is the current minimum? Until now, which is the smallest element? Until now, the smallest element is 0. So our current minimum is pointing here. J is again incremented. Is 5 smaller than 1? No, but again j is incremented. J will be incremented irrespective of whether the element is smaller or greater, in order to check the minimum element. In order to place min index with the most smallest element, the j have to iterate over the array, right side of the array, for the whole time, for the whole right side of the array, the whole of the array. Okay. Now 2, is 2 smaller than 0? No. So the smallest element in the array is still 0, and our current minimum is pointing at that, and we will swap our current minimum, and we will swap our current minimum we will swap our current minimum with our ith index, right? So what give us the resultant array? Minus 1, 0, 1, minus 1, 0. Sorry, this will be 3, this will be 1, 5, and 2, right? Just let me write it clearly for you. Minus 1, 0, 3, 1, 5. Okay, very good. I think we are clear until now. Now, I is pointing here at the next index. Current min is pointing to here only, and j is pointing to the next index of I. Now, is j smaller than is j smaller than 3? Yes. So swap switch the current index to here. Again, j moves to the next location. Is 5 smaller than 1? No. So the current index does not move. Is then the j moves to 2. Is 2 smaller than 1? No. So the current index does not move. Or the mean index does not move. The mean index or the current index are the same thing only. The mean index does not move, and mean index is pointing at location 0, 1, 2, 3, 4, 5 at location 4, and our I is locating to 3. So we now swap our mean index with I. So it gives us a resultant array minus 1, 0, 1, 3, swapping performed, and 5 as it is. Now again the same thing. Now our I is pointing at 3. Our mean index is pointing also at 3, and our j is pointing to I plus 1. Initially, as I told you, this condition satisfies. Initially, every time this condition will be satisfying. Okay, now j is incremented to now first of all, check is performed that whether 5 is greater than 3. No, 5 is not greater than 3, so we don't change the mean index. J is incremented. Is 2 smaller than 3? Yes, 2 is smaller than 3. So mean index is now currently pointing at j. Mean index is currently pointing at j, and there are no more further elements left to be checked at the right side. So we simply swap 3 with 2, means I with mean index. We simply swap I with mean index. Minus 1, 0, 1, 2, 5, 3, and our swapping has been performed. Okay, now let's do the same process again. Our I is pointing at this location, our mean index is pointing towards this location, and our j is pointing towards this location. Now, since j is nowhere left to go, so j just performs the check. Is 3 smaller than 5? Yes, 3 is smaller than 5. So mean index is being replaced. Mean index is now at j. And since there are no more further elements left to be checked, we'll perform our swap. We'll perform our swap. We will perform the swap, and the swap is between error of I and error of mean index. Mean index and I are being swapped. 5. And that's it, guys. As you can see, our array is completely sorted now in ascending order. And since I has reached already n minus 1 index, so no need to do any further thing. Right? No need to do any more further iteration, since I has already reached n minus 1, and our array has got completely sorted. Okay. Now let me write you a proper code for this particular thing. Let's say void selection sort. The the typed code present in the description. You can check that out as well. For the timing, I'm showing you here the code. I'm taking a vector instead of an array, but the process will remain the same. As int n is equal to the size of the array. Let's say array dot size. Now into our first for loop, where we initialize I as 0, I is less than n minus 1, and I plus plus. As I have told you, inside this for loop, we will initialize our mean index as I. We will initialize our mean index as I, and after that we will iterate for our j loop. J is I plus 1 initially, j runs till less than n, and j plus plus j iterates over the right side of the array after I every time. Now if ARR of j, if our j is smaller than ARR of min index, if our j is smaller than ARR of min index, do what? Min index को j से replace कर दो, simply just replace the min index with j. Okay, and that's it guys. This is for the for loop, and at the end of this for loop just perform the swap ARR of I with what? ARR of min index. That I have explained to you here as well. Our for loop ends and our function ends as well, and this particular code works absolutely fine, and it will give you the correct result every time with uh, no error, I suppose. Okay, so that's it guys, it is done, and I hope you are able to understand the code how it has been done. See, if there is any here, the mean index, the mean ind is used to find the smallest element that is present at the right side of I. Mean index is used to find the smallest element that is present at the right side of I, and after finding that we simply swap the position of I and a mean index. That's it guys, and that's it. And j is also used for the same purpose, to help mean index. J is used for the purpose of finding mean index, its smallest element. That's it guys. Okay, I hope you got my idea. And now to check on time complexity. What will be the time complexity of this particular algorithm? And let's say uh, in case of base case, if the array is already sorted in ascending order and you are trying to sort it in ascending order only, in base case it will give us a big of n time complexity. And in case of and in the worst case scenario, it will be big of n square, because for every time, for let's say the worst case will be array is present in descending order and you are trying to sort it in ascending order. That will be the worst case scenario, and in that case it will go big of n square, and in average case as well it might get to big of n square. In case of average case, it may also get to big of n square as well, because for every I we need to check the jth element. J will be traversing through the whole loop after the ith index for every time, every time the I iterates. Okay, that's why it is that. And what will be the space complexity? Space complexity is nothing. It will be big of 1, because we are not taking any extra array or vector to perform our swap. We are performing the swap operation in the given array only. Right, we are performing the swap in the given array only, so we don't need any extra space. Thank you guys. That's it for today. Hope you enjoyed our video. Hope you enjoyed this video, and please do consider subscribing to our channel and pressing that bell icon so that you never miss an update. And also
eyes in the sky, gazing far into the night. I raise my hand to the fire, but it's no use, 'cause you can't stop it from shining through.